So the first session we held in April covered the link float pontoon system and its many uses. This is still available on YouTube if you want to catch up with it. This afternoon's session, we're going to talk about the planning of a machine loadout, ballasting to maintain trim and stability, and safe operation of a machine on a barge or pontoons. Next slide. So a couple of simple rules for the session are please mute your microphone when you're not talking. If possible, turn on your video when you're speaking. Just a note that the call will be recorded and will be available to watch later on. If you have a question, please post this in the call chat bar. Raise your hand if you have a question or a comment. Remember to unmute when you want to talk. This is an open forum and everyone is equal. Please be respectful and please share the knowledge from these sessions with your colleagues. One thing to note with the questions, there is a question and answer session at the end, so we'll save all of the questions and answers to the end of the session. So next slide, please. So I'm Steve Marshall, Director at VolkerMarine Specialist Businesses Limited and responsible for our VolkerMarine Services operations across the UK. Today, I'm joined by Chris Hudson, Engineer and Manager at VolkerMarine, and Hamish Adamson, MD at Harland Solutions. So during the session, we will cover the forces at work mobilising a pontoon with a machine. Tracking onto a pontoon is extremely hazardous, and the load transfer and forces acting are in a very dynamic environment. These will be difficult to establish and control if you're not experienced. How does that movement of the load affect stability of the barge? We'll look at that. Correct positioning of the machine. There's MCA and LOLA requirements for tying down and fixing machines in position. We look at maintaining trim during lifting and slewing. Ratings for lifting operations and how the machine is derated. Holding down deck fastenings and ties. Dynamic ballasting during loadout and operation. Holding on station with winches and anchors and spud legs, and practical examples of a loadout. It's critical that the machine is placed correctly and held in position, as due to the movement of the barge and potentially wet oily surfaces, it's easy for the load or the machine to slide, destabilizing the setup. And to counteract the loads at work, it's often necessary to change the ballasting arrangement during operations to maintain stability and keep the barge in trim. It's also critical that the barge is held on station during operations to ensure the load is not allowed to swing or move. Next slide, please, Natalie. So here's a few examples of what happens when it goes wrong. So the top left image is a well-known incident that occurred in the Netherlands not so long ago when undertaking a tandem lift using two mobile cranes off two barges. You'll later see how quickly the dynamic effects of the loads during the lift destabilized the whole operation with catastrophic results. On the top left, we see an operation on a modular pontoon system in the United States. The pontoon is initially grounded on the riverbed on the left-hand side, and as the excavator rotates, the pontoon moves, freeing the pontoon from the ground. The resultant heel causes the excavator to slide off the deck, again with catastrophic effects. The bottom left shows how bad practice when mobilizing an excavator. The barge could easily push away from the shore, dropping the excavator into the water. And on the bottom right, we see a barge with an excavator in Australia that has been swamped through overloading. So you can see some quite serious effects of getting it wrong when you're operating machines on a barge. Next slide, please, Natalie. The consequences of getting it wrong. So there's obviously property and equipment damage, as you've seen in the photographs. Not only could the excavator crane and barge be damaged during the operation, but adjacent property, the equipment may sink and block navigable shipping lanes and berths as well. Obviously, there's death and serious injury, and falling into swift moving and cold water in a canal or estuary can have serious consequences, especially if an operator is trapped in the machine. Obviously, another side to it is the pollution. Oils and fuel on board the machine is a major concern and will damage the marine environment. Not only that, but you have delay and disruption to the project and marine operations, loss of reputation, and potential loss of opportunities following on from the incident. So next slide, please. So the Marine and Coast Guard Agency, Health and Safety Executive, British Standards, Occupational Safety and Health Administration all produce guidance and standards for operating machines on board craft, pontoons and barges. Much of what we'll talk about today is covered by Marine Guidance Notes MGN 332, the USHA 1926, BS 7121, the LOLA regulations, and of course PURE come into effect as well. It's critical that the marine operations are planned and carried out by competent and trained personnel, as the environment has unique hazards that are often overlooked by inexperienced people with disastrous results. In planning our operations, we work closely with machine suppliers and manufacturers, the pontoon supplier, civil engineers and naval architects to ensure the operations are correctly designed and work is carried out safely. Next slide, please. When selecting barges, you must ensure that you have a plan of what you intend to do on the barge, what equipment you're going to need, what is the layout you require, what loading is the equipment going to impart on the deck, what movements you are going to carry out, how is the pontoon barge going to be held in position, and what are the conditions you are working in. It's critical you know the tidal range and flow conditions, the depth of water, wind conditions and exposure, and whether you're working in fresh water or seawater. So the barge should be sized to ensure that it can support the load of the machine and any other deck loading required, such as storage, piles, etc. You should also ensure that there's sufficient deck space to allow safe access around the plant and equipment for personnel, and that there are safe zones around deck machinery, especially ropes and chains. Any pads for cranes and excavators should have the capability to take the ground bearing pressures from the tracks and tyres under all operating conditions. And this may require reinforcement of the deck through the use of navi mats or spreader beams. And the machine should be prevented from sliding or moving using ties or corrals. Next slide, please. So selection of suitable equipment. Machines mounted on a barge should be derated depending on the prevailing conditions on the barge. Machine manufacturers will advise on the rating of the machine for different conditions. Now it's noted, I attended the Hillhead show in June, and only one excavator manufacturer that I spoke to, and that was Liebherr, would provide duty charts for working over water on a pontoon. All of the other manufacturers deemed it the responsibility of the operator to assess the machines themselves. So you need to refer to an expert to consider the rating of the machine when you're working in the marine environment. Whenever you get a machine and you get the capabilities and the charts, the duty charts, they're usually quoted as standard for working on a fixed horizontal plane. And it's up to the operator of the barge to ensure that the machine is only operated within the design capabilities. This will require ongoing checks on the sea state, the wind conditions, effects of passing vessels, and changes in heel caused by movement of the plant. And BS 7121 covers that in a number of areas. Next slide, please. This is an example of a duty chart that was produced for our 90-ton crawler crane for working on a barge. And you can see it derates the crane for working in this situation, but it also states the maximum trim angle that the crane is to operate in. Obviously, BS 7121 requires a competent person to take into account the possible heel angle in determining the rated capacity. So it's very important when you're selecting machines to work on a barge that you consider that it will be derated and you make sure that the ratings have been assessed by a competent person. Next slide, please. I'm now going to hand over to Chris Hudson, the VolkerMarine Engineering Manager, who will discuss how to correctly manage the temporary works elements of working machines on barges. Pardon me.
Thank you very much, Stephen. Next slide, please, Natalie. Okay, so just a brief introduction for myself. Chris Hudson, VolkerMarine Engineering Manager and the designated individual for the company's temporary works procedure. The Volker Wessels Group have similar persons who undertake that role across the business as designated individuals looking after their temporary works procedures. When we say temporary works, I always like to paraphrase it as enabling works. It gives a little bit more clarity to the individuals within construction what temporary works is, and to just attribute where floating plant fits within that temporary works element. Placing plant or materials on a floating platform should be considered temporary works. We must demonstrate that a platform has structural capacity to carry out the intended loads and can remain stable and buoyant throughout the duration of its use. Sea fastenings at deck level and anchorage configurations for the floating system may also be required. Next slide. So let's talk about a little checklist. Stephen's already mentioned in his presentation earlier about the kind of what, where, why, how of what you should be considering. I'm going to put it a little bit more black and white for you. The temporary works coordinator needs to provide the temporary works designer with a clear and informative scope. What do you want to do? How do you intend to do it? Where are you planning to do it? When are you planning to do it? And why are you planning to do it? Always helps too. Next slide, please. So let's look at the what first. What are you intending to do? Are you intending to move, provide access or operate some plant or materials from that floating vessel? How do you intend to do it? What floating vessel are you using? Is it a barge, a pontoon, a vessel? Have we got sufficient details of the general arrangement, the fabrication of that vessel, and any ballast plans? Regarding materials, do we know the weights of the materials and do we know the center of gravity of the materials? And obviously then we need to look at where the position of those materials sit within the floating platform. In terms of plant details, make sure that you provide sufficient specification sheets, any operation manuals, and specifically lift plans where you're looking to do lift operations. Stephen mentioned earlier, when you're looking at the where, look at the location. Is it open sea, coastal, harbour, tidal, river, lake, etc. Provide the water levels. Be aware of the bed levels too, because this can influence where the vessel sits within the water and whether or not it's going to bottom out. Think about the velocity or wave height and whether you can retrieve that information from anywhere, and if not, what do we need to do to receive that data? Then look at when. Look at the dates of the operations that you're proposing at the start and end dates. Seasonal variation brings changes to the environment that you're going to be operating in. So whether you're going to be doing it in any part of the year, you could be influencing tidal levels, but you could also be looking at weather patterns, which can influence wave height and movements, etc. The big thing that we often miss when we're telling the story on a temporary works brief is the why. Provide a narrative to the project, sets the scene for the temporary works designer and will help them picture the site's conditions and may help them identify any further potential risks. Next slide. So don't be blinkered. Remember that accessing floating plant will also need assessment. It's not just operating off the vessel. Take this into account when you're writing your temporary works brief. What's the vehicle that you're using it and how are you going to access it onto the floating vessel? Do we need to do any quay wall or embankment assessments? And what does the bridging detail comprise? Because those assessments will influence both land and vessel. Next slide. So once all that's done and the design's been in place and you've received it back, what's the next thing that you need to do? Well, you're going to have a look at what you're going to have to manage in terms of an operational duty. So prior to loading, is the floating platform provided the same as was assessed in the design? Is the configuration of the floating platform as assessed in the design? Do you need to undertake a condition survey? Are the pontoon units connected correctly? Is there an appropriate deck protection provided? Are working positions for plant clearly marked? Once you've done all those initial checks, then you're going to go on to the loading. Is static equipment as assumed in the design? We all know that quite often we can order a crane and a different crane turns up for one reason or another. The same goes for excavators. So always check if there's a variation or change in plant, that the weight and position has been assessed effectively before you load it onto the platform. Is the operational plant as assumed in the design in terms of machine type, size and position? And the next question, is the freeboard under dead weights as expected? Freeboard will be mentioned later on in the presentation for anybody who doesn't know what that is. Once in use, is the operational plant as assumed in the design? Again, machine type, size, lifting duties, position, and is the freeboard as expected? On completion, always undertake a condition survey of your barge, pontoon units or deck protection, just to make sure that if any effects have taken place during the operation, at least you can mitigate or explain why that may have happened. You're on mute, Steve.
Yeah, rules number 3, I think it was rule number 3. Always turn yourself off mute. Right, we're going to hand over to Hamish now at Harland Solutions.
Thanks, Steve. Yeah, I'm Hamish Adamson from a company called Harland Solutions, and we work with VolkerMarine on a range of projects, providing assistance with various bits of stability and loading of barges and additional temporary works designed to enable the great projects that they do. If you could go to the next slide, Natalie. So as the previous two gentlemen have said, plant operations are risky at the best of times, and we find that in the marine world as well, the operations are often under-assessed on the risks involved, and complacency definitely sets in these type of operations. You can see in the first photo here, this is one that we performed at Eastham with working with VolkerMarine and Carmet. That's a traditional barge and I believe a 60-ton crawler crane. Again, the engineering and effort into getting this on and off safely is quite considerable, mainly for the reasons that Chris previously mentioned on ground conditions. This is the entrance to the Manchester Ship Canal. You can see the tide range in the upper part of the photo as the tide's going out there, and the conditions involved. And you can see the length of the link spans, which are the mats that connect the barge back to the pontoon to allow the crane to crawl down. You can see the sheer length of those that are required to get back behind the retaining wall and reduce the pressures into the retaining wall. So operating on a floating asset provides a lot higher risks, as we'll touch on through the presentation. The plant importantly needs to be down rated, and as Chris says, as Steve says, sorry, there's a range of companies that offer duty charts, but again, the smaller the pontoon, the smaller the barge, the different the asset, the harder these tasks can become. And so really the size of the barge, as we'll touch on, is a big contributing factor, as is the work that's being doing, which is again why Chris's explanation of the narrative around what is trying to be achieved should always be communicated. Often the worst case involved in these operations is actually in the loading and the transitions, and that's why we often use ballasting, which is essentially the other end of the seesaw. As we're trying to drive this equipment onto the pontoons, we use water ballast to counteract the weight of the machine coming on, or indeed we pump out to aid it. The mooring loads as well, I'm sure everyone saw over in the previous storms. There was a lot of sort of LinkedIn news and industry-wide news about an incident that occurred. Again, the mooring loads, especially in small barges and small plant, is often understated. We work with very large barges covered in with North Sea oil rigs on them and other equipment, and again we can't put those anywhere in the world without a fully approved and verified third-party checked mooring analysis. And yet in the UK often companies are able to get away with just a little bit of polyprop on the side of the riverbank, which again is less than ideal. If you go to the next slide, please, Natalie. So just to explain a bit of terminology that comes into play during barge operations, during this type of work. Really, there are four main things that are calculated during the process of the design, and the important thing is that this each load case considered is dependent on where the boom of the crane is, for example, the boom of the excavator, the various heights. So it's really the temporary works designers, the naval architects involved, to assess what is going to be the worst case, and that's why Chris's description of the narrative is so important. That actually what the operators might think and what the barge masters might think could be the worst case may or may not be. So actually communicating that to determine how many steps are involved in the stability calculation is important. So really the four main things that get reported back is essentially the freeboard. This is the distance from the water to the top of the barge. You have the draft, which is the other bit. It's the bit underneath the water. And then you have the displacement, which is essentially it's the displaced weight of water, which is the equivalent of the weight of the barge. And the GM, and this is a term that's used, and essentially the GM is a calculated distance. You can see it at the bottom here. You have essentially the center of gravity moving up, and the point at which the point of stability is as the center of gravity moves across due to inclination or external forces. The metacentric height is the point of essentially of the rotation. So the taller that is, the stiffer the barge becomes. And as you can see here, I'm sure everyone has probably seen this pub game or charity game that you see on a pub. Essentially, that's a lemon there floating in water. And essentially that is the center of buoyancy of that is slap bang in the middle of the lemon, as you would expect. So as you put the penny on top, as you put the 5 pence on top, the lemon wants to turn over because now the center of gravity has gone higher than the center of than the metacenter. The thing that the lemon has become unstable, and it'll turn over. The only time you get that right and you get the pride of putting your 5p on top of the lemon well is when you land it, much like standing a ruler on its end, when you get it completely perfectly right. But again, that's only good as long as the wind's not blowing and no other external forces happen. You need this GM figure. You need that to allow you to have stability during the forces that will push you over. If you go to the next slide, please, Natalie. So here again, essentially the main things that affect the stability of equipment is number one is the water plane area. And the stability of a barge is actually is proportional to the second moment of area of the water plane. So essentially that means it's a second moment. So as you get twice as wide, you get 4 times more stable. Again, depending on how you're working as well, a lot of traditional barges for towing reasons are 5-6 times longer than they are wide. Whereas sometimes for plant operations, a more square barge like you can build with the VolkerMarine Services pontoons and link floats is more adapt, because then you get symmetrical properties in both pitch and heel. So both of those are important. And then the second factor is the vertical center of gravity. And so Chris mentioned previously, the joys we all go through when a different crane turns up because one's stuck on the A1 or swapped out at the last minute, and we're always last in the line. The actual configuration of the boom, the height of the boom, is very critical for crane operations. When you're doing these calculations, the weight of the suspended load works from the top sheave block. So essentially, all of the weight, as soon as you pick it up off the deck, all of the weight transfers to the top of the crane, and that can cause your instability there. So again, when we're working with cranes, when we're derating cranes, and when we're working together, we work to ensure that the boom length is properly assessed and properly managed. And so the water plane area is very critical, and a lot of the time that we spend is spent looking at the drafts and the freeboards. Because essentially, if your draft goes to 0 or your freeboard goes to 0, then you start to lose water plane area rapidly, because one corner or one side of your barge is is now either submerged or emerged from the water, and then your water plane area starts to decrease rapidly. So essentially what we're trying to do at all stages is make sure that as the cranes are working, you don't lose that water plane area. As all of these barges tend to be squares and with vertical sides, you know, your stability stays roughly the same until that point of deck edge submersion or keel edge immersion. If you go to the next slide, please, Natalie. So here's a nice project where we work with Volkers and VolkerMarine and really pushed the limits on what can be done. So here you can see on the this was building a hydroelectric plant on the River Weaver in Cheshire, and essentially what we were building it in an old sluice gate, around the side of an old sluice gate, where we had to it was on an island with a restricted weight. So the picture on the right hand side is the crane. We actually had to deliver that crane to do the install of the screw that you can see on the left, which is why the second crane in yellow in the smaller picture is there, because we always describe this one as the challenge of the fox, the chicken, and the grain of which one has to go to the island in the right amount of time to be able to do it, because essentially the crane has to be able to pick up its own mats and place them down, because at the far end there is nowhere to deploy the mats. So the specification of all of the crane is to accommodate the lift of the link spans you can see on the right hand photo. So again, this is a 100-ton mobile crane, and we were lifting in the region of 17 tons at 13-meter radius, I think. So yeah, that's what we were doing with that. And then once it was on the island and delivered, we then moved the screw down on a self-propelled trailer, again with different weight categories, different stability issues, down and onto the island for install. Next slide, please, Natalie. So here you can see the some of the photos taken during the loading process. You can see on actually the far right hand side, you could probably tell that the ballast of the barge is that furthest away from the key edge is lower. So we've set the ballast of the barge there, because as we roll over the front edge is obviously going to go down, as you can see in the far left photo, which we reversed on. So yeah, this is definitely loading. It's not coming off, but yeah, we reversed on for practical reasons. As you can see, also because of the length of the link spans needed to get off at the other end, we've actually had to push the whole system further back into the river. So we're now standing off about 8.5 meters, sat on the spud legs as well. And again, the spud leg position is chosen pretty specifically to allow the rotation of the barge during this ballasting operation. And you can see the change in freeboard, which is again the distance from the waterline to the top of the barge, changing through these photos. As far right, no weights on the pontoon, and then the worst case is actually the middle photo, where the center of the slew ring, the middle of the tire sets is right over that front edge of the pontoon. That's pretty much the worst condition. And then, as you can see on the far left photo, that's when the world starts to get a bit happier, and the guys in the office stop sweating a little bit, and things progress a bit better. That's the point where you're safe. But again, in this condition, we weren't actually safe at that point there when the crane is going. If once the crane obviously goes past center, it's then working with the ballast to try and tip you over your backside. So again, the control of the crane and the operation there is very critical, and we wouldn't have been able to do this without the exchange of water, the exchange of and the length of the link spans. So next slide, please, Natalie. So just to explain, this is one of the photos that Steve put up earlier today, and this is one of those projects where, when you review the accident, and there's quite a lot on this. It's called this is in the Netherlands, in a place called Alphen aan den Rijn, and you sit and you listen to the accident investigation. You read the accident investigation, and you think, why did no one stop this? At what point, with all the flags sailing, why was this allowed to continue? And that's the risk that we always run on these type of operations. Someone has to, someone always has to be the bad guy to say this. But all of the analysis provided in the review of this operation said that it couldn't be done, even in the perfect conditions, even with all the things going with it. It would never have worked successfully. And again, this is the big lesson learned on this one is lead contractors taking on the responsibilities thinking they have subcontracted the responsibilities, which again ties in with Chris's design briefs and everything there. But actually, no one party was responsible for this lift, and no one planned the lift successfully. So just to set the scene before we get to watch a big smash, no one was hurt as well. So remarkably, a lot of houses and a lot of pride and a lot of cranes were damaged in this. But essentially, we have 3 barges in this operation. You've got 2 joined together end to end, each with a separate crane on. And then on the you can see in the top right photo, there was the delivery barge for this bridge. So the aim was to pick up the bridge, push the pontoons along the river, and then install it. And just like that, everyone's happy. So Natalie, if you go to the next slide, it should start the video. So you can see it start to slew here, and you can see the barge in the far barge start to roll. The next barge start to roll. First crane goes. Second crane thinks he might get away without getting wet, and then it just touches the ballast, and then that's the whole crane gone. So I think it's a poignant lesson there as well, and we always describe it as a lot of people will think that these things are engineered. They think they've got the right people on the job, and actually the thought process, the reviews, and the understanding of what is going on needs to be thoroughly understood. And again, hopefully, good engineers, good naval architects involved will help to highlight the risks through traditional temporary work design and try and communicate those in the traditional ways, on drawings, in risk assessments, in operations manuals, to really get the points and the lessons across to the people who are doing the work. Next slide, please, Natalie. So just a quick summary on that before I let Steve close up. Using plants on barges requires a little more thought than on land. There's a bit more engineering that goes into it. Again, the loading really needs to be considered and understood. And again, the really working hand in hand with the land loads, the sea loads, and the barge loads all needs to be understood. If it's planned, understood, and communicated, it can be done very safely. We've got a very good 100% track record so far in safe loading of equipment. So long may that continue. But again, it comes through asking questions, from challenging, and from thoroughly understanding what people are intending on doing. I think all people working with the equipment need to be briefed and aware of the conditions. We do a lot of work doing stability calculations on a range of pontoons. And we go out onto site and we manage and help work on these jobs. The amount of times we go onto these projects and the people on the ground haven't received the stability calculations, don't understand them, haven't been briefed on them, don't understand the daily checks, don't understand the stop limits, and so that actual communication onto site, which can often be so easily missed, is such an important part of these projects. And that's where we find that things go wrong. Either there's no planning at all done in the office, or there's no handover of engineering onto the site. The other option that we see is people really pushing the limits. So when we try to design these operations, we go to the extreme limit of what the equipment can do. If the excavator can lift that much at that radius, there's going to be the temptation to do that. We're all used to the usual pressures of working on site and delivering projects. So that's something, if it can be done, people might do it. So again, on the engineering side, the suggested engineering as a very minimum to perform is the loading methodology, including a little storyboard, speaks volumes, means people don't have to read the long documents if that's not their role. The operating stability, to really understand. Again, we try and produce easy drawings as well. These can be laminated. They can be put in the crane cabs, in the excavator cabs, so the guys really know and remember them and are reminded of them. Again, reiterating the operating stability limits during toolbox talks, things like that, we find really helps. Mooring as well, we end up with essentially 2 conditions. One, when it's operating, and then when you wind it off, when you tide it off. How are you going to survive when the barge is essentially unmanned, everyone's gone home and staying in the hotels? And then during as well as the engineering calculations, we suggest a minimum set of sort of procedures, one for the roll-on, one for what we naval architects determine an inclining experiment. But essentially this is, once everything's loaded and you think you're in the right condition, essentially slew your corners, slew around the corners of the barge and check that is as per the engineer's calculations to really make sure that everything has been set up right, and that you're displacing the right volume and your GM is where they estimate it to be. Again, on site you can't operate a telehandler. Steve, you're on mute.
You disappeared there for a moment, Hamish.
Oh, sorry.
Just on the last bit of the inclining experiment.
Oh, okay. No, so just on the the inclining experiment is really the check once all the equipment's on the barge to check that the stability as per the engineering's calculations. Again, that's normally a case of slewing to each of the corners and checking, and then daily checks around. You don't operate telehandlers and forklifts without a daily check. You should be operating barges. And then in moorings as well, we've moorings and man overboard procedures are very important to have on board.
Yeah.
And that's that covers everything.
Excellent. Thank you very much, Hamish. Really, really interesting stuff there. Plenty to think about. So thanks, Hamish and Chris. Quite a bit of information there to take in. I hope it hasn't given you all indigestion having to listen to that and see those incidents. But hopefully it's given you a real insight into how to operate on a barge and on pontoons safely. So we'll now open the floor to any questions. If anybody wants to dip in, please feel free.
So we've got a question in chat, Steve, from Bart Harris at VolkerMarine.
Yep.
Can you give a bit more detail on water ballasting and deballasting of the link floats during loading and unloading and how it's monitored?
Is that one for Hamish? I know Hamish has produced ballasting plans for us in the past, and obviously, that's the one thing to note about the link float is there are 3 chambers per link float with hatches on, so we can flood chambers in the pontoons to create ballasting, but certainly. When we're carrying out critical operations such as mobilisation and demobilisation, Hamish has produced detailed ballast proposals for us, which highlight the amount of the volume of water to put in tanks, around the barge. So yeah, is there anything you want to add to that, Hamish?
Yeah, no, essentially, I think the question was specifically around the link floats. So each of the link floats essentially has 3 compartments, equal size, all of about 5 tons of water capacity, 5 tons of displacement. During that process, we use multiples of 5 tons because it's nice and easy. When the water starts pouring out the top of the tank, we're full, and when you can see the bottom, we're empty. So we try and work in multiples of 5 tons to do that. And again, we during critical roll-on operations, we provide our engineers to site to actually manage that operation with Stephen's guys. It's essentially monitored throughout. We would, in the example, some examples, you can essentially set the ballast first, and then you roll on the equipment, and you don't have to ballast during. That is, if you have a fairly stable pontoon, you have a less stable pontoon like the crane example you saw there, we can essentially drive on, quarter, half of the way, then we have to stop and allow the pumps to catch up before we then can proceed the final amount. So again, there's no sort of hard and fast rule. If you had a infinitely large barge and you were driving on a Ford Fiesta, you wouldn't need any ballasting. But again, if you had a very small barge and you're driving on a 100-ton crane, you have to proceed with caution.
Okay, Got another question from Mark Dawson from Volker Fitzpatrick. What is the role of the naval architect?
So the naval architect is a traditional word. You know, it's the same as a shipwright. I myself am a naval architect, but again, you know, you wouldn't start pouring concrete or doing anything like that without talking to a civil engineer. You know, you wouldn't disassemble the gearbox without talking to a mechanical engineer. So it's really just you know, in your toolbox of people, having a naval architect is the type of person you need for these marine operations. So we know. Hopefully know all about stability, strength assessments, motions, and current and wind forces.
Not bad, mate. Whereabouts are you working a minute? What unit are you in?
I think someone's come off mute.
Yeah.
Oh, there we go.
Okay, we got that one. We got one more question from Dan Livermore, who's another engineering manager at Volker Stevian. Have you ever been challenged about edge protection on link spans?
Yes, where we provide them in-house. We have 3 edge protection solutions. So we have a GRP lightweight handrail system, we've got a steel handrail system, and we also have a chain handrail system. And our view is that, you know, wherever we've got guys operating on the pontoons, we provide handrails. Obviously we hire it out to the market, and there are other people who will operate them without handrails or without adequate protection. But we do provide that as part of the system, and certainly, you know, our belief is where we've got men exposed to men overboard situations, then we should have handrails.
I think Dan's question was really on the link spans. Is it, Dan?
Yeah, on the link spans, and as well just about vehicle restraints as well. Like I say, I appreciate it's a very controlled operation, but it's just something that's always struck me. That it's always just 2 very basic beams across to a pontoon, isn't it?
Yeah.
Well, probably we've just created a floating roadway for a line, which is for public access, and that has full road restraint on it. Something that Hamish has designed for us, and that's it's a structure that's going to be in place for a possibly, you know, 18 months or longer, and that has a full road restraint system, because it is public access. I mean, the image you saw there on the River Weaver, that was certainly the screw, the Archimedes screw, was put on using SPMTUs, which were remotely operated. So, you know, there was no need for a man to access that link span, and obviously the crane was put on under a very controlled operation. You know, so yeah, where appropriate, we do provide handrail systems.
Yeah, I think on the actual loading and on link spans, most of the time the practicalities, especially on excavators and things like that, it's just not possible to have them on there. Normally for pedestrian access, we would put a gangway on, but again, in the situation you saw there, we can't actually have the gangway on because of the deck space available to do the operation. So in return, we had obviously anyone who touches these barges, we have life jackets on everyone, and we actually put safety boats in the water. And we had 2 safety boats in at the time there for rescuing, and that's the way we mitigated that, because there was no physical way of getting the crane on with the handrails in place.
Okay, a question from me. Over the Christmas period, it was in the kind of construction news that there was an issue with floating plant on a construction site over in Leeds, where an excavator mounted on a pontoon got away from its moorings or its anchorage and floated down the river, colliding with some in-river assets, leading with the excavator falling into the river and the pontoon carrying on down the river. What kind of checks from a construction site perspective or operation should we be undertaking to make sure that kind of thing doesn't happen from a lessons learned perspective?
That one for you, Hamish. You've mentioned berthing processes and checks.
Yeah, I mean, we work quite a lot in oil and gas. I mean, recently we've just been planning for the load in of free full oil rigs, including 1,500-ton jackets and 700-ton, 1,000-ton topsides on barges 130 meters long by 36 wide. Again, the mooring analysis that we go through in that we perform a quasi-static mooring analysis for that. We look at the maximum current data, wind data, everything like that for the conditions. Again, same sort of thing that you can get out of the local annexes of Eurocode 3. And again, actually, the physical drag calculations, when you're being as simplistic as you need to be for these barges, is very simple. It's force over area times a coefficient. Actually, all of that can be done. The harder bit tends to be getting reliable current data for the rivers that we're working in. And then again, a lot of the sites you probably saw there, there's no real bollards, there's no real fendering, anything like that. So all of that we're then looking at as well of how do we actually restrain this when we need to. So I think again, I haven't seen the site of the Leeds incident, but I can assume the root cause was somewhere along a bollard failing or a rope failing at some point. And so normally that's best case you see quite big mooring ropes, but then they're normally ragged and have served a long time, or you find that they're using a bit of 12mm polyprop that was found was holding the ballast pumps together, or was found on site, and the mooring tends to be very much an afterthought, but also the fact that people sometimes only consider the operating condition and then don't revert back to fully understanding the survival condition, which dare I say it, Leeds in winter is not a nice place to be necessarily.
Good, thanks for that. Anything else? Anybody else got any questions they want to?
There's a response in the kind of question section just from Bart, just saying the mooring lines for the pontoons in Leeds also looked too short for a rising water level and pulled the pontoons under. So yeah, that's an interesting perspective from a tension perspective. You could get destabilizing effects if the water levels increase too much or decrease too much.
Yeah, definitely.
One last question from myself.
Mm-hmm.
In terms of using, say, the link float pontoons as an example, is there a maximum depth of water that they can be used in, Steve? And if they were to bottom out, are they structurally sound up to a certain limit?
They were designed to bottom out. However, we wouldn't recommend bottoming them out unless it was onto a prepared flat surface. We have supplied them to contractors who have been working in beach environments where they've prepared the ground, and allowed them to settle onto the beach. They do have a rubbing strip underneath to allow them to land onto the hard, and like I say, they were designed to bottom out under full load conditions. The worry for me is, certainly, if you're working them in a tidal zone, there's no guarantee where you're gonna end up in, and it's very easy to destabilize the pontoon if it lands on one corner, before the rest of the pontoon, so it's not ideal. It can be done, but I wouldn't recommend it. And in terms of conditions, they are designed to work in areas with up to a meter swell. And they are certified by the MCA for working up to a mile offshore, inshore waters. So yeah.
Okay. There's a question which Natalie might be able to answer in terms of sharing of the presentation and contact details. Can you just give us an update in terms of how the recorded event's going to be managed from a Volker Wessels perspective?
Yeah, the recording will be uploaded onto YouTube, but we will send an email out with the recording and also the presentation slides. If contact details, if you need anything from the guys up in the team at VolkerMarine Services, either get in touch with Steve or Chris Shorrock, or you can also think it's email info@volkermarineservices.co.uk.
Well, if that's the last of the questions, just say thank you to Hamish and Chris for joining us, providing a very informative presentation. Thank you all again for joining us. Hope you found this session interesting and it's given you some thought as to how to safely operate machines on pontoons and barges. And if you've enjoyed the session, please feedback to either through the chat or email after the end of the session. And if you do have any other questions, you can email us directly. If you'd like to see us cover more topics, then let us know. We are developing a program of lunch and learn sessions, and the next one should be up for delivery in about 3 months' time. So we'll hope to see you all there. So enjoy your afternoon, and goodbye. Thanks now.